Hey, eighth graders, this is Mrs. Shepard coming back with some more information about triangles, specifically with tracking isosceles and equilateral triangles. So this first slide's got a note card, which means I want you to get this information on a note card. It's basically giving you the names of all the parts of an isosceles triangle. It's really important that you understand what those names are. So I'm going to draw a little picture here to show you what each of those pieces are. The vertex is the point that connects the two congruent sides. The two congruent sides, by the way, are called legs. And then the two angles formed by the leg and the base are called, get this, base angles. I know, super cool. All right, so just make sure, let me pull this down. There we go. Just make sure that you understand what those are. If you just want to put this picture on a note card, that would be fine too. Again, the intent is to have people quizzing you on your note cards. One of the theorems we're going to talk about is, there's two of them here because one's the theorem and one's the converse. And remember, with the converse, you take the hypothesis and the conclusion and you flip them. So the isosceles triangle theorem says, if two sides of a triangle are congruent, then the opposites, the angles opposite those are congruent. So with the isosceles triangle theorem, we're given an isosceles triangle. So we can then say the opposite angles, the base angles, are congruent. The converse says if the two base angles are congruent, then we can say that the opposite sides are congruent. Okay, so understanding the difference between those. I would put those on two separate different note cards, one for the theorem and one for the converse of the theorem. So taking a look at some examples, name two unmarked congruent sides. Okay, so when I look at this, I'm going to use the converse. I know that two angles are congruent, which tells me that their opposite sides are congruent as well. Then what we can do is then say that CB is congruent to BD. All right, and I'm putting the name over the top of them. The next one says name two unmarked congruent angles. All right, so then I've got CB and BA are congruent. That means I'm going to use the theorem to say that angle BCA and angle BAC are congruent. So angle BCA is congruent to, not triangle, angle BAC. Here we were using the converse. Here we're using the theorem. Remembering those as you go through. All right, taking a peek at this picture, name a set of congruent angles and explain why they are congruent. Okay, well, we have PML because they're given, right? Angle PML is congruent to angle PKL, and that's because it's given, right? We also can say that angle JML is congruent to angle JKL. Because these two sides are congruent, this angle is congruent to this angle. And we got to make sure we name them right. We can't just call it M and we can't just call it K because there's actually three angles from the vertex K and three angles from the vertex M. And so with this one, we're using the isosceles triangle theorem. And name a set of congruent segments and say why. In this case, MP and PK are congruent. MP is congruent to PK. Why? It's because of the converse of the isosceles triangle theorem. Okay, be practicing these. Be practicing these. All right, equilateral triangles. Some corollaries. Again, corollaries come directly from a theorem. So a triangle is equilateral only if it is equiangular. It goes back to what we were talking about when we were classifying them in 4.1. Each angle of an equilateral triangle measures 60 degrees. Then we can say that it's equilateral. Okay, so these corollaries just come from that. Find the measurement of R. Okay, well, when you're looking at this, because 5 centimeters, because these two sides are congruent, we know that angle R and angle P are congruent. All right, it's using the isosceles triangle theorem. If P and R are congruent, and we use the triangle angle sum theorem that says the measurement of P plus the measurement of R plus the measurement of Q equals 180. Okay, so let's look at what this looks like. The measurement of P plus the measurement of angle R plus the measurement of angle Q, that equals 180. All right, we know Q is 60 degrees. And we know that if we call PX, we can also call RX because they're the exact same measurement. So we can say X plus 60 is equal to 180. We can then say that 2X is equal to 120, so X equals 60. So we can say that both of those angles are 60 degrees. PR, find the measurement of PR. Well, if all those angles are the same, then it also means it's equilateral, which makes it 5 centimeters. And again, we have to give reasons for everything we say. Whenever it says explain, I am looking for a theorem, a definition, a postulate, a corollary, anything to give us proof why that works. Okay, find the value of each variable. So when I look at this, I know that these two sides are congruent because it tells me that. Okay, so I've got that 6y plus 3 plus 8y minus 5 is equal, or I wrote that wrong. They're equal to each other. Okay, so 2y is equal to 8, so y equals 4. Now, when I look at this particular one, when I'm looking at x, because FD and FE are congruent, I can then say that angle D and angle E are congruent because of the isosceles triangle theorem. Okay, so then I know that all three of those angles equal 180. So 3 times the quantity 4x minus 8 is equal to 180. So 12x minus 24 equals 180. 12x is equal to 204. I think I did that right. So then I'm going to take 204 divided by 12, and x equals 17. So here is your task. Remember to check your answers, submit them with its score at the top. Let's make sure we're, really paying attention to those details. We have one more section left in this chapter, and then we'll be wrapping it up. So until next time.